Good afternoon. So I know a few faces in the room. My name is Ian Cotton. I am in electrical and electronic engineering, so I do all things power systems and high voltage. So we have a very big high voltage lab in the university, so that's where I do my research. I also, though, work both to support energy research across the university. So with Teresa, who is at the back, we try and support anybody doing research across the faculties of the university. And I also work with the sustainability team on helping academics engage in sustainability. And as Emma said, part of the seminar series, what we really want to do is get ideas in how students and staff can engage with the estate and with the city and create challenges or problems that people can look at as part of the undergraduate curriculum, the postgraduate curriculum. And hopefully in a moment I'll give some examples where the estate and information has played a role in our own energy research and some good examples of that. And then Sean's going to tell you about energy from a estate's perspective, the amount of energy that we use, our carbon targets and that sort of thing. So, just first of all, I thought it worth just reflecting on energy research at the university and the areas in which we work. And energy is huge at the university. There's about, and this number varies day to day, 150 academics who are PIs or CIs on research grants. We are just updating the financial figures at the moment, but the last time we looked, we had about £75 million worth of energy R&D ongoing. And you can see there's a huge diversity of topics, some things that you would regard as not particularly sustainable, some things that most definitely are. But we really have a huge activity in energy research at the university. If you want to find out more about what the university does, find out some more of the people who are engaged, then easiest way is go to the energy website. You can see the link at the bottom here. There's contact details on the energy website for both Teresa and I. So if you do want to know any more about any particular area, please do ask, and we can certainly try and help and get you to find people. Energy is one of the 5 research beacons of the university. So the other person who is sitting here today, which I will quickly flag up, is Vicky. So Vicky's at the back. She's the marketing and communications officer, manager for the research beacon of energy. So if you have any story you think the university can tell about energy research, what we're doing in any form of energy, Vicky is your person to see and to help you tell that. You know, energy being a research beacon is really reflective of how much activity we do have. If you just go onto the university website and you go onto the news site, you'll find a number of stories about what we do in energy. These were ones I just quickly copied off this morning as 4 of our most recent energy research stories, and you'll see there, so things from Dalton Nuclear Institute at the top left, things from MIB, the Institute of Biotechnology, on the bottom left-hand side about liquid fuels and new pathways from biomass. You've got something at the top right-hand side. I'm not sure whether that came out of chemistry or chemical engineering, but to do with fuel cell efficiency. And then something on the bottom right from Tyndall Centre to do with policy. So it's well worth going and have a read of those sort of stories. On the energy website, there's publication highlights, which Teresa writes once a month. I'm sure they're all up to date. There you go. So go and have a look at those, and they tell a really interesting story about what we do. So just moving on, I thought I'd just give you a couple of examples of research projects in energy and actually start to explore how some of these begin to link in with the estate. So this is a snapshot of one project which was recently completed. This was a £1 million EPSRC project called ResNet. And this was between Elec and mechanical engineering, and particularly Tyndall. We also worked with the University of Newcastle. But this was an example of a project that looked at the impact of climate change on the UK energy system. And the reason I wanted to talk about this one is in a moment we'll see some of its conclusions and understand how they would inevitably impact on the university campus itself. So this project, without going into extraordinary technical detail, we had basically a climate system. So we had weather models going up to 2080. So we could generate synthesized weather as if climate change had taken place. And we could get profiles of temperature, rainfall, wind speed in the future. We still have access to that capability, so if anybody's interested in that, and that's based on UK CP models, let me know, because we can generate this theoretical future weather. And it's all scenario-based, it's all probabilistic, but it's very, very useful. We had scenarios looking at demand and supply of energy, and of course we know the way in which we generate energy is changing. Coal is effectively gone. We've got a lot more gas. Nuclear, I would say there's still quite a big question mark about. We are committed to Hinkley. Will Moorside, will New Wilver, will those other nuclear sites go on? We still don't really know politically. They may not. We are, though, seeing an awful lot of offshore wind. Still seeing a growth in onshore wind, even though politically it may not be as favourable as it once was, and solar. And that demand change is having a massive impact on the next layer, the energy network itself. So the big overhead lines, the substations, all of those are seeing massive changes because of the way in which we use energy. And that is already being felt. So this project was looking at these big impacts, and it was particularly interested in what's the impact of climate change going to be on the energy system, but also what's the impact of mitigating climate change as well as adaptation. And it was really this figure I wanted to share with you, and I apologise, you guys might be a bit far away to see this clearly. These graphs were looking at the amount of energy that might flow through the electricity system, and I stress the electricity system, in the future, with and without climate change. Now, if we want to go to a low-carbon future in the UK, the general wisdom is we've got to stop using things like gas. We've got to stop using oil in the form of petrol, diesel, and other heating fuels. Now, if you get rid of gas, you get rid of oil. The only effective medium to transport energy that remains is electricity. So there's been a big focus to do things like electric vehicles. Electric vehicles are great, but you've got to plug them in, and the network has to manage that load. Heating is even worse. Most homes use about 8 times as much energy in heat as they do in electrical energy. So if you displace that load on to the electricity system, it will be really, really difficult for them to cope. If I just wander over this way, just to show you really the scale of the change. So if we actually just focus on this one, which is probably the really interesting one, this top graph is winter. Okay? And this is winter 2010, this is winter 2050, and this is the change in the way we think we will use energy in the future. And the big difference between 2010 and 2050 is the increase particularly in the amount of energy used for domestic heat. So to heat our houses, we'll use more and more heat pumps or electric heating instead of gas, and more cars and electric vehicles. So the amount of energy the system might use at peak goes from about 60 gigawatts up to about 100 gigawatts. So we may need to pass 50% more electricity through the electricity system going forward. This bottom graph is more interesting though. This is summer. And in summer, historically, our demand has always been lower than our winter demand. So our peak demand in the UK is always in the winter. We use more electricity for heating, for lighting, for cooking. Look at what happens in 2050. If climate change takes place, in 2050, we have this huge electricity consumption from commercial air conditioning. So one of the potential big impacts of climate change, which is important for the energy system, could be increased increased temperatures, the increased need for cooling, and if commercial entities use air conditioning, that could increase our summer load on the electricity system from 50 gigawatts to well over 200 gigawatts. So when people talk about all of these things about smart grids, they're really important because they're not just to do with getting more electricity through the big overhead line pylons, and they're not just about balancing wind. They're about, can we use the energy systems that we have, the wires under the ground, can we use them more efficiently to actually supply these very, very high level of powers? Instead of having a very peaky curve, do we smooth it out? So people are talking about smart grids, and a lot of the work that goes on within the university from a research point of view is smart grid dominated. And it's probably smart grids that have most strongly linked to how people have used information from the university campus in their research to date. And that's really what I wanted to focus on just for a couple more minutes. If I can get the slide to move forward. So this slightly small project, slightly small pictures again, probably for that side of the room, I'm afraid. This was a project called DIMMER. DIMMER was a European Union funded project, a Framework 7 project, and it was looking at the interplay of different energy systems. So within the university, and Sean, I think, will pick up on this in a bit more detail in a moment, we obviously have an electricity system within the university. Every building has electrical power. A number of our buildings have gas, but certainly a lot of our systems, a lot of our buildings don't have gas going into them. A lot of our buildings instead have heat going into them. So the university has a big heat network, and we pump hot water or steam around the campus. So this research project was actually saying, how can we use these systems more effectively at different times of the day? Can we, for example, take electricity, and can we do clever things and use electricity to actually do power to gas? Can we, for example, produce hydrogen that you can pump to some extent back into the gas network that then we could use for heat? You can even use heat for cooling. Or similarly, do we use electricity to run heat pumps to inject heat into the university heat network? And in the future, people expect these different energy networks, the electricity, the gas, and the heat, to be more interconnected and to operate more as a system as opposed to individual components. I should say I talk about all of this kind of on the technical level and from an engineering point of view because I'm an engineer. And I often get reminded by people, technically, a lot of this can be delivered. What's challenging, of course, is the people within these buildings and the users and how they will use the systems which are connected to these. And as engineers, it's really important that we understand the influence of people on these systems. Within the university, we've also got some other really, really good research platforms. So we've got a couple of people in the audience who look after this lovely beast, buried away, in the depths of the Sackville Street building. I suspect there's a timing on this slide. Is this energy storage system. And this energy storage system is a big battery storage system, and we can actually store energy at peak times. We can inject energy back into the grid. And we're doing all sorts of really interesting research with this facility. I always regret the fact that you can't really see a lot of these really good things that we have. They're buried away behind a locked door for very good reasons to do with safety. But if anybody is interested in energy storage, we can certainly put you in touch with the people. We can also now get data off the university estate. So working with Sean and colleagues, this is just a good example of we've got data from the energy management system from estates into an Excel spreadsheet. Now, that's not particularly exciting. But it will mean later this year, students and staff from across the university should be able to access energy data. And we've got within the system, we've got energy data, we've got weather data, we've got transport data, we've got air quality data. So we've got quite a lot of interesting data sets that people will hopefully be able to pick up and use. And again, I'd like to see students, undergraduates being given these to use in student projects. And it could be, could we do a behaviour change campaign to see how we can change the energy use within this building? And we can see, can we financially incentivize people? Is there a link between weather and the energy use within specific buildings? And estates have a load of questions they would love to ask students, and questions that could be set, but we need to make sure students can get access to these data sources quite readily. And just really finishing off, here's just another example of what people did playing about with that data. So this was a piece of work, ignore the actual y-axis scale in terms of real pounds, shillings and pence. Somebody looked at the energy use and they took all of the energy information from our energy metering system, and they actually asked the question, how can we optimize our energy system? If we use energy at different periods, if we can switch certain things on at certain times, certain things off, what can you do? And these were various cases to say if you optimized it for one particular market, or you switched other things off at a certain time, this was the financial payback that you could get. And it's this sort of work and this sort of research we'd really like to connect back with the states to see how we can give value in what we do as researchers going forward. Just finally, looking outside the university, there's a huge amount of activity within the city of Manchester with energy. We are well connected with the city. So again, Teresa and I, depending on who's free, we go to something called the Greater Manchester Energy Group, which sits quarterly, and it's got the city council on, people like Co-op, Peel Energy, Electricity Northwest, Arup, Jacobs. But they look after big projects happening within the city. So there's a big project called Triangulum and another one called City Verve. If you haven't seen those, look those up. City Verve is one of these Internet of Things projects, but it's all about sensors, and people want to do things with sensing systems, building management systems, occupancy sensors, and see how you can use these clever, smart systems to change energy use. Two that we've contributed to, one is this thing called the NADO trial. In this project, 600 houses in Manchester were fitted with heat pumps. And these were social housing locations in Manchester. So heat pumps fitted in to help the people in those houses have lower energy bills. But in return, those heat pumps could be controlled such that the impact on the electricity network was mitigated. So the heat pumps would run at certain times of the day. They wouldn't run, for example, at say 5 o'clock when energy demand on the power system was really, really high. So that was a really good project in that we delivered something valuable from a social housing perspective and yet got some really good research outputs from it. That's being scaled up, and the energy systems catapult are doing a big piece of work now in the city, and actually Greater Manchester, I should say, to do with smart systems and heat, and looking particularly at if you have this need to decarbonise heat, how do we best do that across Greater Manchester? And decarbonising heat in the city centre, in flats and apartments, is very, very different to decarbonising heat, say, in Buxton or in a rural location in Derbyshire, where the infrastructure is very, very different. So huge opportunities, again, within the city if people wanted to get connected. And at that, I think, I am done. So I think we're going to pass on to Sean.